Okay, so now we're going to do the same thing. We're just going to do some more transformations. In example number 2, they're giving us g of x is equal to a times the quantity x minus h cubed plus k. So there's no b term, all right? There's no b term. And it says identify the values of h and k from a point of symmetry. H and K is kind of like the inflection point, right? So in a lot of the other videos, we say that H and K is like the vertex. Yeah, it's like the middle point, but there's a very technical term in math called the inflection point, but it's like the center, right, or the middle, like you said. But the formal math term is inflection point in this particular case. I'm not going to explain why it's called the inflection point. You'll be like, oh, stop talking, Mr. Adams. But H and K occurs right here, right? So then we know that H comma K is 2 comma negative 2. Or I'm sorry, 2 comma 1. And so once we have H and K, the only thing we have to do is figure out what A is. So basically we have this graph, and we have 2 points, and they're asking us to find the equation. So I know what H and K are, but what's A? Oh, I don't know. So the only thing that I need to know, and think I'm going to rewrite this in terms of y equals A times x, we leave x as x, minus h, but h is 2 cubed, plus k, which is 1. But I need to figure out what A is. Well, isn't 3 an x value and isn't 4 a y value? Yeah. So could I say, and I'm going to scroll down here, I'm going to write it out. If I say, what was it, 4? Yeah, 3, 4. So I take that same equation, y equals A times the quantity x minus h, but the h was 2, not 3. 2. Did I write that down right? Yeah, 2 raised to the third power plus 1, right? And I know the point 3 comma 4 exists on the line where this is an x value and this is a y value. Then I could solve for A, because if I plug in 4 for y, leave this as A, and plug in 3 for x plus 1. Now I'm going to give you a second to kind of digest. What I've done is I've gotten rid of all the variables except for one, A. I plugged in a bunch of numbers. Now, if I have a variable and a bunch of numbers, can I solve for that variable? Yeah. So what I'm going to do is I'm going to do the math. Remember, we need to follow our order of operations. Please excuse my dear Aunt Sally. This gets kids sometimes. Parentheses is first, yes? What is 3 minus 2? 1. So I'm just going to put a 1 there. Are there any other parentheses? Nope. Done with that. What's the E stand for? Exponents. What's 1 raised to the third power? 1. So on the next line, I'm going to say, well, let me write it out so you can think about it. 1 to the third power times A plus 1. 1 to the third power is 1, so we've got 4 equals, what's 1 times A? A plus 1. How do I get A by itself? Oh, Mr. Adams is writing too fast again. I got my hair cut. The lady cut it a little short. I haven't had my hair cut like this since I was 9. All right. So what do I do to get A by itself? Subtract 1 from both sides. What is A? 3. So these cancel, and then 4 minus 1 is 3. So A equals 3. So now, let me scroll out here so you guys can see everything. We know what A is, don't we? What's A? 3. So let's put that in there. So A is 3. So there's a lot of words that are written down in your book. And that's what they're saying. You can identify the value of A from either one of these two reference points. That's what we did. We plugged them in. Now they use this stuff. I don't like this stuff. Just ignore this stuff. Just ignore this stuff. It's kind of helpful, but I prefer you guys practice and do it this way. So at the end of the day, this equation, and it's written down here, is G. Can I zoom in real quick, guys? Yeah, so this is G of X is equal to A, which is 3, times the quantity X minus H, which is 2, raised to the third power, plus K. And so all I did is I plugged in 1 for K, 2 for H, and now 3 for A. Does that make sense? Cool, cool, cool. All right, I'll leave that up there for a second so you guys can make sure that you write it all down. Let me zoom out first. Cool, cool,